Variables and graphs. This is the first video of chapter 1 of the course Math 5D02 Mathematics for Natural Sciences. We introduce the term statistics first. Statistics is the scientific method of collecting, organizing, summarizing, presenting, and analyzing data, and thereby drawing valid conclusions and making reasonable decisions. Population and sample. In collection of data, the entire group of individuals or objects under consideration is called a population. A small part of population is called a sample. Example, in the case of height of students in a university, the entire students is a population, whereas student from a district or a college is a sample. Now we define the term variable. Variable is a symbol like X, Y, H that can assign any set of prescribed values. The values assigned by the variable are called the domain of the variable. Now, variable may be continuous or discrete based on whether it can assume any value between two given values. If it can assume any value between two given values, it is a continuous variable. Otherwise, it is discrete. For example, let H be the height of students in our university. Then H is a variable, since if a student has height 162.45 and another has 162.50, a third student may have height 162.47, so that the variable is continuous. Whereas the number of students in colleges under a university, like 1192, 1193, etc., but it cannot be a number between 1192 and 1193. So it is a discrete variable. More precisely or generally, all observations resulted by measurements are continuous data, and those resulted by counting are discrete data. Rounding data. If we round the number 72.87362, the nearest 1000th position, we get 72.874. That is the position of 3. The third place after a decimal. If we round it to nearest 100th, we get 72.87. Nearest 10th, we get 72.9. Nearest whole number, we get 73. What we have done is, we add 1 to the rounded position when the first digit succeeding it is greater than 5. When it is exactly 5, we round it to the nearest even number. So 72.465 is rounded to 72.46, not 7, whereas 72.435 is rounded to 72.45. Accurate digits apart from 0 needed to locate the decimal point. The number 65.4 has 3 significant figures. 65.40 has 4 significant figures, but 0.0018 has only 2 significant figures. The digits 1 and 8 are only 2 significant, but for 0.00180, the number, the zeros after non-zero digits is also significant. So 0.00180 has 3 significant figures, and 1.8 into 10 raised to minus 3 has 2 significant figures. Now we go to computations using significant figures. If we add, multiply, and subtract, multiply and divide by significant figures, we have to follow some rules. In multiplication and division and finding roots, the rule is like that. The final result cannot have more significant figures than the number with the fewest significant figures. For example, in 73.24 into 4.52, 4.52 is the number with the fewest significant figures. Therefore, the answer cannot have more than 3 significant figures. So that the answer is 331. In the second problem, 1.648 divided by 0.023 has, in the first term there are 4 significant figures, but whereas in the second term only 2 figures are significant. So the answer contains only 2 significant figures. Now root of 38.7 is like this. It is 6.22. In addition and subtraction, the final result cannot have more significant figures than numbers with the fewest significant figures after the decimal. Now, 3.16 has 2 significant figures after the decimal, and 2.7 has only 1 digit after the decimal. So the final answer can have only 1 digit after the decimal. So we round the number to 5.9. Okay, we get 5.86. We round the number into 5.9. In the case of addition and subtraction, the rule is like this. Final result cannot have more significant figures than the numbers with the fewest significant figures after the decimal. In the first number, in the second number, 83.42 minus 72, there are 4 significant figures in the, there are 2 significant figures after the decimal in the first case. In the second example, 83.42 minus 72, in the first there are 2 significant figures, but in the second there are no significant figures after the decimal. So there cannot be any significant figures after the decimal. So that the answer is 11. Similarly, in the third case, we get 47 minus 25, 47 point. Similarly, we get 47.816 minus 25 equal to 22. Okay, this is the end of the first video. Okay.